Good morning, Griffins. So today we are going to continue with our solving systems of equations. The other day we did solving systems of equations with graphing, and because we graphed two lines we had an ordered pair. We're going to be doing solving systems of equations by substitution today. So starting off, remember a system of equations is two or more equations. Today we're going to be focusing on just two equations, so our solution is going to be an ordered pair. Remember, an ordered pair needs to be in parentheses. And then we have a system of equations. You can have no solution, just like when we graphed we had parallel lines. If we have no solution for today, the variables will be gone, they're going to cancel each other out, and then we're going to get a false statement, so something like 2 is equal to 5. A system of equations, remember, can also have infinitely many solutions. And again, the variables will have disappeared, and we're going to end up with a true statement. So we're going to do one of every problem. So to solve a system of equations by substitution, we need to make sure that one of the equations is solved for one of the variables. So we're going to be dealing mainly with x and y today. So one of the equations needs to be x equals, or the other equation, or one of the equations needs to be y equals. If it's not, then we need to solve for x or y. We're going to substitute that equation in for that same variable into the other equation. And then we're going to solve for whatever variable we've got left. And then we're going to put that answer. So whether it's an x equals a number or a y equals the number, we're going to put that back into the other equation to solve for the remaining variables. So it's not, I know the steps sound like a lot. It'll be okay. So this one, the first one we're going to solve is an example of a no solution. So remember, we said a no solution ends up with the variables disappearing and we get a false statement. So the first thing we need to make sure is that we have a variable. One of the equations solved for the variable, and we do. We have y is equal to 3x minus 2. So we're going to take what y is equal to, 3x minus 2, and we're going to put it into the other equation where we see the y. So this becomes negative 3x plus, and we're going to put in what y is. 3x minus 2 is equal to 2. And then we're going to simplify. So I have negative 3x plus 3x. Well, those equal 0, so I have negative 2 is equal to 2. Well, since that's a false statement, this would be an example of a no solution. So the variables will have cancel each other out, and I end up with a false statement. So this one is going to be an example of infinitely many solutions. So again, I need to make sure that I have an equation that's solved for one of the variables, and I do. So this first one I have is y is equal to, oops, sorry, I forgot the x again. This is negative 3/4 x plus 3. And I'm going to put that into where I see the y. So this is going to become 6x plus 8 times, and I'm going to put in parentheses, negative 3/4 x plus 3, and that equals 24. So then I need to simplify, so I'm going to need to do distributive property. So I have 6x plus, I have 8 times negative 3/4. 8 divided by 4 is 2, times 3 is negative 6x, and then 8 times 3 is plus 24 is equal to 24. The positive 6x and the negative 6x cancel out, gives us 0, and I'm left with 24 is equal to 24. That's a true statement, so this answer would be an infinitely many solutions. Okay, because I have the variables cancel out, and I'm left with a true statement. Now this next one is going to be an example of a system where I'm going to have one solution left. Now remember, I said I need to have the equations, one of them solved for y. I have two different equations here. It does not matter which one you choose to solve for y. I can choose either one of them. So if I just take the top one and I solve this for y, I'm going to add x to both sides of the equation. So that will cancel out the minus x and the plus x. That leaves me with y is equal to x plus 2. And I usually just write the variable first. So I'm going to substitute this x plus 2 where I see that y. So this is going to become negative 2x plus, and then y was x plus 2, and then that equals 1. So then I'm going to simplify. Negative 2x plus x is negative x plus 2 is equal to 1. I'm going to subtract 2 from both sides of the equation. Negative x is equal to negative 1. Divide both sides by negative 1, and I'm left with x is equal to 1. Now I'm going to take that x is equal to 1 and substitute it back into, and it doesn't matter which one of the two equations. So I'm going to take this x equals 1 and I'm going to put it in for that x. And that's going to give me negative 2 times 1 plus y is equal to 1. Negative 2 plus y is equal to 1. I'm going to add 2 to both sides of the equation, so y will equal 3. And then that gives me the ordered pair of x is 1 and y is 3. And you can check it to make sure you get the right solution. So this would be negative 1 plus 3, and yes, that equals 2. And for the second equation, I get negative 2 plus 3, and yes, that equals 1. So remember, your ordered pair is going to be your solution. So make sure you take your x value and your y value and write it as an ordered pair. So here's our first practice problem. So we already have an equation solved for y. So what will be the new equation? So I'm going to take what y equals 3x plus 2, and I'm going to substitute it in for the y. So this gives me 2x plus, and then y is 3x plus 2 is equal to 2. So now I'm going to simplify. I add the variables. So 5x plus 2 is equal to 2. I'm going to subtract 2 from both sides of the equation. So 5x is equal to 0. Divide by 5. So x is equal to 0. So now I'm going to take that x is equal to 0, and I could put it into either one of the two equations. I'm going to take this x is equal to 0, and I'm going to put it into this equation. So I have y is equal to 3 times 0 plus 2. So that means y will equal 2. So my solution is going to be the ordered pair 0, 2. And if you substituted it back into the equation to check, 2 times 0 is 0, so 0 plus 2, that equals 0. And then y is 2, so 2 equals 0 plus 2, and that's a true statement. Okay. Our next practice problem. I need to have one of the variables solved for. I do not have either one solved for. So this one you can actually choose. And I think this is a typo. This should be a y, so I apologize. This should be 3y. So then you can choose either one. I could solve the top one for y, or I could solve the bottom one for x. I'm going to go ahead and solve the top one for y. So I'm going to add 2x to both sides of the equation. So that's going to give me y will be equal to 2x minus 5. And I'm going to take this 2x minus 5 and put it in for y. So then this becomes, the new equation is going to be x plus 3 times, I'm going to take 2x minus 5, and that's going to be equal to 6. And then I need to simplify. So I have x plus 6x minus 15 is equal to 6, and then I add my two variables, so 7x minus 15 is equal to 6. I'm going to add 15 to both sides, so 7x will equal 21. Divide both sides by 7, x is equal to 3. And I'm going to take this answer, x is equal to 3, and I'm going to put it back into an original equation. Don't put it back into one that you changed, because if you get the answer wrong it's just going to work on something that you started off with, something that was incorrect. So go back to an original equation. So I'm going to put x is equal to 3 there. So that gives me 3 plus 3y is equal to 6. I'm going to subtract 3 from both sides. So 3y is equal to 3. Divide both sides by 3. Y is equal to 1. So my ordered pair is going to become 3, 1. And if I check it, it gives me 3 for x, negative 6 plus 1. Yes, that equals negative 5. And on the bottom equation, it was 3 plus 3 times 1, which is 3, which is equal to 6. Okay, so